بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 1.6 applications of functions and applications of functions in business and economics. We will talk about total cost, total revenue and profit in the first part of this section. Well, the profit is the difference between the revenue, which is the amount it receives from sales, and the cost. So if the number of units produced is X, then the revenue would be a function of X. If you increase the number of units sold, the revenue will be more. And the cost also is a function of X, the number of units produced. Increasing X, increasing the cost. The profit would be the difference between the revenue and the cost. Rx is the total revenue. Cx is the total cost of production. How to find the total revenue Rx itself? To multiply the number of units X by the price per unit. Okay, so what is the price? So for example, if you produce 10 units, each with price 100 riyal, and 10 times 100, your revenue would be 1000 riyal. The total cost usually composed of two parts. Fixed cost, we will call it FC, such as depreciation, rent, utilities. Fixed costs are fixed amount. It doesn't depend on the production, the number of units. It's just a number. And the variable cost, and that depends on the number of units produced, the variable cost. So the variable costs would be always a function of X, the number of units produced, while the fixed cost is a number, fixed, and the cost will be the sum of these two, the total cost. For example, suppose a firm manufactures MP3 players and sells them for $50 each. So now from here, we can write the revenue function. If X is the number of units produced, X players. So if the firm sells each player for $50, so if the firm sells X players, so the revenue would be 50 times X, where X the number of players, and 50 is the price of each one of them, the selling price. The costs, so this is the revenue. The costs incurred in the production and sale of the MP3 players are $200,000. So this is the fixed cost, plus $10 for each player produced and sold. So this is the variable cost, which depends on the number of players produced and sales. So we can write the cost function as the fixed cost plus the variable cost 10 for each player, and the number of players is X. So 10X. Write the profit function for the production and sale of X players. We said that the profit function is equal to the revenue minus the cost. So it is 50X, that's the revenue, minus the cost, which is 200,000 plus 10X. So it would be 50X minus 10X, that's 40X, minus 200,000. So this would be the profit function. Marginals. We have seen here that we are dealing with linear functions. The cost is linear, the revenue is linear, the profit is linear. The slope of the profit function is called the marginal profit. Okay, it represents the rate of change in the profit with respect to the number of units, delta P over delta X. The marginal profit in example 1 would be, this is the profit function, this is uh, the marginal profit, which is the slope, 40. The marginal cost, similarly, is the slope of the cost function. And the marginal revenue is the slope of the revenue function. So here what we mean by marginal. So suppose that the cost in dollars for a product is this one. This is the total cost. As you can see, this is the fixed cost and this is the variable cost. This is a linear function. Where is the slope? This is the slope, the coefficient of x. So when he asks about the marginal cost is 21.75. What does it mean? It means delta C over delta X, cost over X. So increasing, if we increase X, which is the number of units, by 1, the cost will be increased by $21.75. Okay, dollar. So that's the meaning of the slope, delta y over delta x. Y here is C and x is x. Checkpoint, suppose that when a company produces its products, fixed costs are and variable cost is per item. Write the total cost. So the total cost would be the fixed cost, which is 12,500 plus 75 times x, the variable cost. Are fixed costs equal to C0? If you replace x by 0, you will get the variable cost. So yes. So this means that the fixed costs is always the y-intercept of the cost function. Suppose the company in problem 1 sells its product for $175 per item. So the revenue in this case would be 175x. Find R100. Well, to find R100, what is the revenue of producing 100 items? You just multiply 175 times 100. So this would be the revenue, $17,500. Give the formula for profit in terms of revenue and cost. Well, we know that the profit is the revenue function minus the cost. Find the profit function for the company in problem 1 and 2. So the profit function would be the revenue minus the cost. The revenue is 175x minus the cost function, which is 12,500 plus 75x. So it would be 175 minus 75. So that's 100x minus 12,500. Okay, another point, break-even analysis. Well, if we solve the equations for the total revenue and the total cost simultaneously, we will find the point of intersection. And this point where the cost and the revenue are equal is called break-even point. So break-even point is the point where the revenue and cost are equal, or the point of intersection between the revenue and cost. Graphically, the break-even point is the point of intersection of the graphs of the total revenue and the total cost. And let us have this example. A manufacturer sells a product for $10 per unit. So this is the selling price. So this will give you the revenue. If the number of units sold is X, then 10 times X would be the revenue. The manufacturer's variable costs are 2.5 per unit. So the cost function would be 2.5 times X, that's the variable cost, and total cost of 100 units. So there is a fixed cost which he did not talk about. So let us call it F, capital F. He says the total cost of 100 units. So the cost of 100 units would be $1,450. So we can use this information to find the value of F, the fixed cost. So let us uh, substitute with this information here in this equation. So C100 would be 1,450. So C is 1,450 and X is 100. So 2.5 times 100 plus F. So I just replaced X by 100, C by 1,450 according to this information. And now I can solve and find the value of the fixed cost. So it's 1,450 minus 2.5 times 100, which is 1,200. So this is the fixed cost. And I have now the total cost would be 2.5x, the variable cost, plus 1,200. So we were able to find the fixed cost using this information given in the question, that the cost of 100 is 1,450. How many units must the manufacturer produce each day to break even? Okay, to break even, breaking even means the revenue equals to the cost. So this is the revenue, this is the cost, they should be equal. So 2.5x plus 1,200, this is the cost, should be equal to the revenue, which is 10x. Well, if you take x to the other, if you bring 2.5 here, so we will have 1,200 equals 10x minus 2.5x. So 10 minus 2.5 is just 7.5. And then x would be 1,200 over 7.5, which is 160. He is asking about how many units, so the number of units. So this is the answer. So the number of units should be 160 units. 160 units he will break even if he produces 1,160 units. Identify two ways in which break even can be found. Well, we have seen that break even can be found when the revenue equals cost function. But if you remember the definition of the profit is the revenue minus the cost. So in fact, if the revenue equals to the cost, then the profit would be zero. So these are the two ways. Either the revenue equals to the cost, or you put the profit equal to zero. The next part in this section is talking about supply, demand, and market equilibrium. Well, the point of intersection between supply and demand will give you the market equilibrium. when the quantity of commodity demanded is equal to the quantity supplied, we will get the market equilibrium. Now, the demand is related to the price. When we increase the price, the demand will be decreased. And when we decrease the price, we will have more demand. This is called the law of demand. Well, while the law of supply, when we increase the price, the quantity supplied increases. And when we decrease the price, the quantity supplied decreases. So we will usually use this. Q is the quantity supplied or demanded, and P is the price, which represents here the which we usually traditionally we put it on the vertical axis. So on the vertical axis, we will put always the price, and the quantity demanded or supplied would be in the x-axis, and that's why the equation would be also always solved for P, because P is representing the y-axis. So P would be equals to 1 over 10Q plus 5. This is the supply. And the demand negative 1 over 10Q plus 35. So both supply and demand are given by P, price, and they are functions of Q, the quantity. You notice that the supply is always increasing because when the price increases, supply increases. And the demand is always decreasing because when the price increases, demand decreases. And the equilibrium quantity would be here, this point, or this value of Q. And the equilibrium price would be this value of P. And this would be the equilibrium points, Q and P. So you should know the equilibrium price, the equilibrium quantity, and the equilibrium point. Both will make equilibrium points. For this example, 150 and 20, this is the equilibrium point, where the equilibrium price is 20 and the equilibrium quantity is 150. So consumers are willing to purchase the same number of units that producers are willing to supply, which is 150 when the price is $20. Now, this is an example. Find the market equilibrium point. So to find the market equilibrium point, it is the point in which demand equals supply. So demand is given by this equation, supply is given by this equation, so the two equations should be equal. So negative 3Q plus 36 should be equal to 4Q plus 1. If I take 4Q to the other side, then I will have negative 7Q. And if I take 36 to this side, I will have 1 minus 36, which is negative 35. And then Q would be negative 35 over negative 7, which is 5. So this is the equilibrium quantity. Finding the equilibrium price would be easy. Replace Q by 5, either in the first or the second equation. So I will find P of 5, which is 4 times 5 plus 1 using the second equation. So this is 21. So the equilibrium point is quantity is 5 and price is 25. So this is the equilibrium point. A group of wholesalers will buy 50 dryers per month if the price is 200, and 30 per month if the price is 300. They will buy. So that's the demand. So the demand function has 2 points. 50 dryers, this is the quantity. 200, this is the price. So this is the first point. PQ, QP, sorry. And the second point, 30, the quantity would be 30 if the price is 300. So using these 2 points, we can find the demand equation. Remember, the demand equation is a linear equation. So, or the demand function is a linear function. So it's enough to know 2 points, and we can use the equation y minus y1 equals m times x minus x1. But y here is p, so we can say p minus p1 equals m times q minus q1. So I can say this is q1, this is p1, and this is q2, p2, for example. So the slope would be p2 300 minus 200 p1 delta p over delta q 30 minus 50. So I will have 300 minus 200 is 100 over 30 minus 50. This is negative 20. So the answer would be negative 5. So the demand function would be P equals, or P minus P1, which is 200, equals to slope, which is negative 5, times Q minus Q1, which is 50. So P would be negative 5Q. Negative 5 times negative 50 is positive 750, plus the 200 when you bring it to the other side. So it's plus 950. And you can check now that, for example, if Q is 30, then the price is, yeah, so I checked. Let me see this again. Negative 5Q. This is P minus 200. And this is Q minus 50. Yeah, 5 times 50 is 250, sorry. So there is a mistake here. This is 450 instead of 950. I found this mistake when I checked when Q is 30. So now I do it again. Negative 5 times 30 plus 450 will give me the 300. So that's okay. So now this is the correct demand equation. Notice that the slope is negative, and that's always the case for the demand. The slope would be always negative when it's a linear function. Now, again, the manufacturer is willing to supply. He's talking now about supply function, 20. So this is the quantity, Q1. If the price is 210, this is P1. And 30, this is quantity 2. If the price is 230, price 2. But these are 2 points in or on the supply function. So to find the supply function, we do the same. So we find the slope. The slope is 230 minus 210 over 30 minus 20. This is 20 over 10, so that's 2. So the supply equation or supply function would be P minus 210 equals to the slope times Q minus 20. So when you solve for P, I will have 2Q minus 40 and plus 210 when you bring it to the other side. So it would be plus 170. And let me check my solution. So 2 times 20 plus 170 should give you 210, and 2 times 30 plus 170 should give you 230, which is the case. So this is the supply equation, and this is the demand equation. And I believe this is what we needed. Our linear find the equilibrium. No, he even needs the equilibrium points. Good. So the equilibrium point, the demand function should be equal to the supply function. So negative 5Q plus 450 should be equal to 2Q plus 170. So if I take 2Q to the other side, I will have negative 5 minus 2 minus 7Q. 170 minus 450 is negative 280. So Q is negative 280 over negative 7, and that's 40. So this is the equilibrium quantity. And to find the equilibrium price, I can use the supply, replace Q by 40. So 80 plus 170, that's 250. So that's the equilibrium price. He is asking for equilibrium point. So the equilibrium point would be the quantity, equilibrium quantity, and equilibrium price. This is the point of intersection between the supply and demand functions. Checkpoint. Does a typical linear demand function have positive slope or negative slope? If you remember, we said the demand has negative slope. And the reason? Because when price increases, demand decreases. Okay, decreases. Does a typical linear supply have positive or negative? We said it is positive supply, and the reason when P increases, supply increases also. What do we call the point of intersection of supply and demand? That's market equilibrium or equilibrium point. If supply is given by this equation and demand is given by this equation, find the market equilibrium point. The market equilibrium point is when the supply equals the demand. So if we take this to the other side, 0.1 plus 0.1 would be 0.2Q, and 130 minus 20 would be 110. So the equilibrium quantity would be 110 over 0.2, and that's 550. And let us find P. Let me use the supply. 0.1 times Q, which is 550 plus 20. So the equilibrium price is 75. If you replace Q in the demand equation by 550, you should also get the same answer. So equilibrium point would be the equilibrium quantity, which is 550, and the equilibrium price, which is 700. 50. So at this price, the supply will be equal to the demand. That's the end of this lesson. Thank you very much.